Hello team and welcome back to the channel. Today's video is going to be really interesting and very important for people who are learning DevOps or people who are preparing for DevOps interviews. So in today's video, we are going to see how we can build and deploy application to multiple clusters. So basically a few months ago, I was working on a project where I was deploying application to multiple clusters. So the process that we followed there, same process I'm going to show you here so that you can understand in real time how this kind of deployment to multiple clusters happen in companies. Okay, so make sure to watch this video till end so that you don't miss out any of the steps. Also team, if you're new on the channel, make sure to subscribe so that you don't miss out any of the videos. You will find tons of amazing hands-on videos on DevOps as well as on cloud DevOps. Also team, for people who are looking for dedicated training sessions on DevSecOps and cloud DevOps, you can enroll to batch 6. Batch 6 is starting from tomorrow 30th of July. As of now, we are having a discount and you can get this course for 7559. Talking about the projects in the course, so we are going to have total 10 hands-on projects which we are going to implement. These projects are of different kinds. Some projects will be Java, some will be in .NET, some will be Python, Node.js, and so on. All those projects we are going to implement, plus we are going to have a microservice based application also, so that you can understand how we are building and deploying microservice based applications. Talking about other kind of applications, so 3 multi-tier applications we are going to have, in which I am going to explain you how we can connect a database to our application. That also we are going to do hands-on. So the database that we are going to cover is Postgres, MySQL, and MongoDB. All 3 databases I am going to show you how we can connect to applications. Plus there will be some real world applications. So in total you'll be having a vast variety of knowledge on different kind of applications. Plus at the end of this course, I'll be helping you one-to-one to prepare your resume. And if you are transitioning from different domain to DevOps, I'll be helping you to understand different kind of projects. So all those things will be included in the course. And as I say, today is the last day to enroll, because from tomorrow we are starting this batch. So make sure to enroll. Okay. For any queries, you can ping me on WhatsApp or Telegram. All the details will be in the description. Now with that being said, let's get started. So team, now let me explain you the flow that we are going to follow in order to implement this whole application. Okay. So I have prepared one diagram and let me explain you what exactly we are going to do and in detail. Okay. So yeah, getting started from here. So let us say that we have the application ready and client says that, okay, I want to modify the application or add some buttons or some new feature or like any kind of update client want to do. For that, what client is going to do, he's going to create a Jira ticket, and that Jira ticket will be taken by a developer, because developers are the one who is going to write the source code for the application, right? Okay, so once developer has taken the ticket, they are going to create a local copy of the application repository in their local machine. Okay, once developer has created a local copy, then developer is going to write the source code for adding the new feature. Once developer has written the new source code for adding the new feature, then they have to test it locally. Okay, by testing locally means they are going to implement or run the application in their local laptop or in their personal laptop or office laptop, whichever they are using, to check and confirm that the code that they have written to add the new feature, it is working fine. Once the code is working fine, then developer is going to push the code to GitHub repository, and generally we are going to use 2 branches. Let us say dev branch and prod branch, prod or main branch. Okay, so first of all, developer is going to push the code to dev branch. Okay, as soon as new code is pushed to dev branch, automatically a pipeline will be triggered, and not Jenkins. We are not talking about Jenkins. Jenkins is the different scenario. Automatically what is going to happen, we are going to use GitHub Actions. Okay, because it's as I always said that GitHub Action or GitLab CICD, they are much better than Jenkins. Okay, so automatically a pipeline will be triggered on push trigger, like that pipeline will be getting started immediately as soon as the something is pushed to the repository of dev branch. Okay, GitHub Action will start the pipeline. First, what is going to happen? First, we are going to see compilation of the source code. Compilation basically means that we need to basically it's going to check the source code if there is any syntax based errors or not. What is syntax based errors? Basically, for example, let's say I missed out somewhere a semicolon or any bracket or anything, those kind of things. If they are missed, then we say that, okay, there is syntax based errors, and then there will be the error of compilation failure. Okay, So once let's say this is code is fine and compilation is successful, then it will move to next step, which is to perform or run the unit test cases written by testing team. Okay, so it's going to execute all the test cases to make sure that application, like basically checking the functionality of the application if it is running fine or not through the unit test cases. After that, we want to check the basically the application folder or file system, and perform dependency check on the dependencies being used in the project. This can be done by a tool known as 𝗘𝗅𝗏. Okay, it can find out if like for example, when we are working with a Java based project, all the dependencies of the project are mentioned inside the pom.xml file. So we need to make sure that whatever dependencies we are using, they are not outdated, they are not vulnerable, and they are perfect. Okay, there is no any kind of issues in our dependency. That can be found out by 𝗘𝗅𝗏. Okay, after that, we want to check if there is any kind of bugs or any kind of vulnerabilities in our source code. That can be done by SonarQube code quality check and code coverage. Okay, code quality check is basically going to find out if there is any kind of issues in the code. By issues, what I mean, bugs, vulnerabilities, code smell, those kind of issues, if they are present in our source code, then we will be able to find out using SonarQube analysis. Code coverage is basically means that what percentage of code is covered by running the unit test cases. After that, we are going to run quality gate check. Basically, quality gate check is run because we might be having some threshold that if our source code, the number of the lines of code or percentage of code, if it is 80% covered by test cases, then we say okay, code quality is good, and basically this is the code coverage. Okay, this 80% that we see, that the percentage of code that is covered by unit test cases, that is known as code coverage. Okay, so if less number of issues are there in our code, and if code coverage is more than 80%, then we say okay, quality gate check is passed. Okay, this process also we can implement. Next up, we are going to build the application to generate the executable file. In case of Java, executable file is nothing but a file in the format of jar or var. Okay, as you know, jar file can be easily run by running the command like java-jar, then name of the jar file. In this format, we can execute the application, right? So for that purpose, we are going to build the jar file. After that, we are going to build the Docker image, and then we need to scan the Docker image using the same tool 𝗘𝗅𝗏 to find out if our Docker image is having any kind of vulnerabilities or not. Okay, once that is done, then we are going to push the Docker image to Docker Hub repository, and then using that Docker image, we are going to create our YAML manifest files, and then using this YAML manifest files, we are going to deploy the application to dev cluster. Dev cluster is the lower environment. Okay, once this is successful, then now talking about the most important thing, basically when we are going to deploy the prod cluster. So once we see that everything is running fine in dev cluster, then the Docker image that we just created, as you can understand from all this process, that the Docker image that is created, it is already passed all the issues. That means this Docker image that is pushed here is not having any kind of issues, right? Unit test cases are successful, code quality check is done, then dependency check is done, right? That means this Docker image is already qualified and ready for deployment to prod environment also. So next up, what we are going to do, for example, let us say our dev cluster Docker image was, let's say this one, dev latest. So we know that okay, this Docker image is completely fine, it has passed all the security checks. So what we are going to do, in order to deploy this in our production environment, we are going to tag it with different name. We are going to name it like prod latest, like that, and then this Docker image will be used for new YAML manifest files for prod cluster, and then we are going to deploy the application to prod cluster. And this is what exactly we are going to follow today, and I'm going to show you for each of different environment how we are going to write the pipelines to integrate to basically execute them automatically. Okay, so yeah, make sure to once you implement it successfully, make sure to post it on LinkedIn. It will be really useful for you. You can tag me as well. Okay, so now let us start by like what exactly things we need to do now, right? So now what we need to do, first of all, we need to set up clusters, right? In clusters, what things we need to set up? One we need to set up as prod cluster, one we need to set up as dev cluster. So prod, I'm going to set up EKS. which is going to be managed by AWS. And for dev cluster, I'm going to set up a self-hosted uh, uh, Kubernetes cluster. Okay. Once we set up, then we can start writing the pipeline for each one of them, and then I'll show you how exactly everything is being done. Okay. So now let us get started with this one. So team, now we need to set up our cluster. Two clusters where we need to set up. One is prod, one is dev. For dev, I'm going to set up self-hosted Kubernetes cluster. So for self-hosted, what we need to do, we need to take virtual machines and then we need to set those virtual machines as master node and worker node. Okay. Before that, you need to make sure that the certain ports are open on your inbound rules. So in the security group, maybe you can take a screenshot. These are the ports that I'll be opening because these are the ports that I use on regular basis. Once we have done that, we can create our virtual machines, and I'm going to create two virtual machines. One will be for master, one will be for worker node. Okay. And I'm going to take Ubuntu machine. Version will be LTS version 24.04. And size of the machine that I'm going to go with is going to be T2 medium. Key that I'm already having on my local, which is DevOps key. If you are doing this for the first time, make sure you are creating your own key, provide a name, RSA key pair type, and make sure the format is PEM. Then you need to click on create key pair, and this will be downloaded on your local machine, which you can later select from here. Network settings. So the security group that I just showed you, that's what I'm going to select. Storage, I'm going to go with 25. And now let us create this. Once we have created, we can let us wait for this to come up. You can see these are in pending state. We can name this as master node, and it will be second will be worker node. Okay. Now we need to make sure that they are online. So let me refresh the page, and you can see now they are in running status. So now let us one by one connect to these machines through SSH. First, open master node, copy the public IP address, go to MobaXterm. It's a tool that can be used for connecting to your virtual machines very easily. Click on session, SSH, provide the IP address, username. Since we have created Ubuntu machine, so username will be Ubuntu. Then we need to provide the key that we have downloaded, right? So for that, click on advanced SSH settings, click on use private key and browse to that location where you have kept the PEM file of the key. Select that, click on OK. Okay, let me close this and let me rename this immediately so that we can have a proper format. Okay, so I can name this to master, and let me select the color also. Color is fine. Now I need to select a duplicate of this. Let us rename this, and this we want to call as worker. We need to change the IP address to the worker node, right? Which we can get from here. I'll copy this and paste it here. Okay. Now master node and worker node are created, but we need to configure them so that our cluster can be set up. Okay, so let us access them. Okay, now Control L to clear the screen. Now first command that you are supposed to run is going to be sudo apt update. It's going to update all the default packages that are present in the Linux repository for usage. Okay, same thing we need to do on worker node. Here also I'll run the command as sudo apt update. Okay, once this is done, next up what we can do, we need to execute certain command. So first we need to execute command on all the nodes, that is worker node and master node. These are the list of command that we need to execute. So in order to avoid executing them one by one, what we can do, we can copy them all and execute them through a script. We can create a script vi1.sh, paste the commands here, save this, and make the see, if I run ls, you can see it's white in color, right? That means it is not executable now. So we need to add the permission to get executed. That we can do using sudo chmod +x, then file name, which is 1.sh, and now we can execute it by running this command /1.sh, enter. Okay, same thing we need to do here. Create one file vi1.sh, paste the commands here, save this and make it executable. Sudo chmod +x 1.sh and execute this. Okay, so yeah, let's wait for this to complete. Once this is completed, then we can go ahead and execute the second command. Second command that we need to execute, that is only on master node. Okay, so let's copy this first command, and yeah, so on master node command set executed, so we need to execute this, which is basically initializing the port network. Okay, click enter, and this command, what it's going to do, it's going to generate a token also, which can be used by worker node to connect to the master node. Okay, so let's wait for this. So team, now basically the command that we just ran, the initialization command, that has been completed, and these are the results, right? Here you can see this step. Then you can join any number of worker node by running the following on each as root. That means in order to add a worker node, basically add a virtual machine as worker node for our master node, we can run this command, right? That also we need to make sure that we are running it as root. So I'll copy this command, go to worker node, and here I'll run the command as sudo, then run paste the commands, click enter, and let's wait for this to complete. You can see here this node has joined the cluster. So team, once the worker node has been connected to the master node, next up what we have to do, we need to execute these three commands. What they need to do, basically it's going to create a folder, kube folder, inside which we'll be having a kube config file. Kube config file is a file that is going to be used for authentication, because it also contains detailed information about the cluster. Okay, so we need to execute these three commands. So you can directly copy this and execute it on the master node, and second one this one, and last we have this one. Okay, so these things are done. Next step, we need to set up two things. One is going to be 𝗘𝘅𝗰𝗹𝘂𝗀𝗃 which will be used for networking, and next up we are having ingress and nginx controller also. So both of them we need to install. So I'll copy this and directly run here, but we might get an error. Okay, no error, fine. And second thing that we need to execute is this one. Copy that and execute on the master node. So let's wait for this to complete. Now both of them are completed. Now what we can do, we can test out if our cluster is up or not. So I can run the command kubectl get nodes, and here you can see currently status, it says not ready, because it takes few seconds or few minutes to completely get up. So let us run the commands again, and now you can see the status ready. That means this is the control plane, this is the master node, and this is the worker node. Okay, that means cluster is set up, and that is fine, right? Next up, what we have to do, we need to set up our second cluster, which is going to be production cluster, right? Now production cluster I'm going to set up properly, and that's going to be EKS cluster. So for creating EKS cluster, what we need to do, we can use Terraform. Now in order to run Terraform commands, we need to create separate virtual machines. From that virtual machine we can run it. We can do it from local also, but I find very much easier for like running the command directly from a separate virtual machine. Okay, so I'm going to create another virtual machine, and let us name this as Terraform server. Take Ubuntu machine, version will be 24.04, and size will be T2 medium. Key pair already we are having, and security group the one that I'm using, right? And storage I'm going to go with 25. Click on launch instance, and let's wait for this to come up online. Okay, now we need to connect to this, so I'll copy this, go to MobaXterm, click on session, SSH, IP address, username it's going to be Ubuntu, and here we can select the private key from our local. That is done. Click on OK, and let us just rename this to Terraform server. Okay, color also, if you want, you can just select it, it's up to you. Let me close this, and let us connect again. Now you can see we are connected to our Terraform server. First command, always remember sudo apt update. Once this is since this is being run, next thing that we need to do, we need to set up AWS CLI, because that's how we are going to access the resources on our AWS account. Okay, so team, now we have to execute the commands for installation of AWS CLI, so that we can communicate with our AWS account. Okay, so I can run this, and let us see. It's taking few minutes. Okay, so this is done. Once you have installed AWS CLI, you need to run the command as AWS configure in order to provide the credential for connecting to your AWS account. Okay, you can see it is asking for access key ID. Now where do we get it? So for that you need to go to your AWS account page, and two options we can have. One option is that you can create resources. You can create specific user, provide it some specific roles to that user, and then create the credential for that user for connection. Okay, just for demo purpose, what I recommend, see, this is first of all not a recommended practice, but just for demo purpose, what I can do, I can create the credential for my root user. Okay, you can go to this open this profile, click on security credentials, and on this page you can create a new credential. Okay, I'll remove the old one. Before that, we need to make sure that we are deactivating it. Then you can click on create access key, click on this and create access key. Now we have the access key, copy that, paste it here. Then secret access key, that also you can get it from here, copy that, paste here. Next we need to provide the region name. Region in our case, it's going to be AP-South-1. Where do I get it? So you can go here global and you can choose the region that is nearest to you. For me it's Mumbai, so I can put the AP-South-1. Okay, and click enter, and just again click enter. Now you are connected to AWS account. Now what we can do, we can run the Terraform command to create EKS cluster on AWS. Okay, so we need to make sure that we have Terraform installed. I can run this command. You can see Terraform is not present, but we got the command to install Terraform. So we are going to install it using snap package, and we need to make sure that we are putting ---- classic. If not, we are going to get error, and let me show you that as well. You can see its error is coming, right? So we need to make sure that at the end we are putting ---- classic, click enter, and you can see it is running now, right? Now, in order to execute Terraform commands, we need to have the Terraform files, right? That is present already on my repository. In mega project cluster, and here we have main.tf file first, copy that, and here let me create a directory mkdir EKS cd EKS, and here we are going to create one file vi main.tf, paste the contents that we just copied, paste it and save this. Okay, second thing that we need to create output.tf. Because of this file we are going to, whatever the resource is getting created, so its detailed information we can get through this file. Okay, you can see cluster ID, node group ID, and these things. So I'll copy that as well, paste it, save this file as well. Okay, and last thing that we need to set up is variables.tf. So I'll copy this and let us create last file, vi variables.tf, and paste the contents that we just copied, save this. Okay, now first command that we can run, you can see all the three files are created. First command that we need to run, terraform init. This is going to initialize whatever plugins or file, whatever is needed for Terraform to run. All those things will be initialized here. Okay, and you can see it's done. Next command we can run, terraform apply. If I right click enter, it's going to ask us a prompt, basically asking us permission to execute the Terraform command. You can see here, do you want to perform these actions? So here I need to put yes. If you don't want that, you can just add here ---- auto dash approve. This will automatically assume that permission is given and it will start creation of resources. Click enter and you'll see that it's going to start the resource creation. You can see in total it's going to create 17 resources, including virtual machines, cluster, VPC, subnet, and whatnot. Okay, so all those things will be created and this will take few minutes, basically 5 to 10 minutes it's going to take. Okay, so just be patient, and once this part is completed, then we'll be back. So team, as you can see, it's still working. It's been 5 minutes. As I said, it's going to take some time. Okay, now let it be. Now we can get started with writing the pipelines for our dev cluster. Okay, now for doing that, first of all, what I'm going to do, we are going to use this repository and we are going to first of all create a new branch. And new branch, let me provide the name as dev. Okay, dev branch we are creating from main. So we have created. Next up, what we need to do, we are going to use GitHub Actions to perform the CI/CD, and for that we need to make sure that we have our own runner. Okay. So for setting up runner, you need to go to settings, and you can see this option actions. Second option is runner. So click on that, and this is the old one. So I'll remove this, and let me remove by giving the permission for my phone. It's because MFA is enabled on my GitHub. Okay. So this is done, and remove this. Now we need to add new runner, right? So click on new self-hosted, and here we need to select what kind of runner we want to use. So we are having Linux machine, so I'll click on that. And these are the commands that we need to execute on the Linux machine to make it as a runner. Okay. That means we need to have one virtual machine. So for that, I need to create one virtual VM. Okay. Click on EC2 and let us create one machine. I'm going to name this machine as runner. Click on Ubuntu. Our version is latest one, 24.04 LTS version, and size will be T2 large. I'm taking. You can go ahead and work with T2 medium also, and this one the key pair, and finally the security group. Storage, I'm going to go with around 30, and click on launch instance. So let's wait for this. Yeah, this is here. So I'll copy this and let us connect to it. So I'm going to create a clone of worker node, and I can rename this to runner, change the IP address, and let us change the color also. I'll just go with something like this. Okay, and this might take few seconds to completely come in running state. Okay, and let us double click on this runner, and yeah, we are connected now, right? This is good. First command, always remember, do not forget sudo apt update. Meanwhile, we can check out what steps we need to execute. For Linux, first of all, we need to create this folder. Okay, so I'll copy this step and we can execute it here. Let's wait for this to complete. Okay, paste it here, click enter. Next step we have, which we need to execute, basically downloading a package that is required for making a virtual machine as a runner for GitHub Actions. Okay, this package basically contains all the required files and whatever things are needed. After that, we need to, this is optional, so do not execute it. No, not required. Next up, we need to extract the file that we have just created, downloaded, right? Now let's wait for this. Okay. Here you can see we have, these are the files and shell scripts created inside the available inside the package. First of all, I'm going to remove this tar file. Okay. And now we are left with these files. What is the next step? Next step is to execute this command. Copy that and execute it. Now you can see, now we need to basically set up or register our virtual machine as runner. Enter the name of runner group. So by default there is no runner group created, so we can simply go with the default one. Okay, name of runner, it's up to you what you want. I can go with runner -1, click enter, and following labels are created so that your pipeline will be able to identify where exactly does it needs to run. Okay, and next up you can see it says runner successfully added, so that's good. And then it says enter the name of work folder. So by default it's _work. If you want to change it, you can provide some other name. I'll just go with default one. And now runner is set up. Okay, now runner is set up, but still if I go here and click on runners, you can see it is set up, but it is still in offline state. How we can make it in online? So bring it in online state. We can run the script run.sh. Once we execute this, then this runner will come in running like online state. Okay, before we do that, few things I need to do. First of all, I need to make sure that we have maven installed on this machine. So I'll run the command as sudo apt install maven -y so that no prompt comes. And along with maven, I'm also going to set up 𝗘𝘅𝗰𝗹𝘂𝗀𝗋. So 𝗘𝘅𝗃, I can run search, click on the first link, since we have Debian Ubuntu machine, so I can copy the command, and this is going to install 𝗘𝘅𝗰 on our machine. So I'm going to install that as well. Let's wait for this. Okay, so this is done. Okay, now we can start the runner. So for that I can run the command as run.sh, and let's see what happens. You can see it says connected to GitHub. Now it's listening for jobs. Basically it's waiting for jobs to come online. Okay, meanwhile here also you can see our EKS cluster is set up, but in order to make sure that we are able to access it, one more command we need to run, which is going to be this one. Basically update our 𝗘𝘅𝗰𝗹𝗂𝗀 file, because 𝗘𝘅𝗰𝗹𝗂𝗀 file is the file that is going to be used for authentication, right? So run this command, and now we can check it. kubectl get nodes. You can see kubectl is not present, so let me install it quickly. --classic, because we are installing with snap package. Okay, so let's wait for this to complete, and then we can confirm that okay, our cluster is running fine and we are able to access it. Okay, now if I run this kubectl get nodes, you can see these are the worker nodes and they are in ready status. That means now it's online, right? Now we can get started for writing the pipelines. So team, next up what we can do, we can set up our CICD pipeline. Okay, so what we can do, first go to actions, and in action section you'll be able to find a lot of templates which you can utilize to write your or get started with writing the pipeline. So I'll go with Java with Maven, click on configure. Okay, now problem is you can see it's written main. Okay, but as of now I don't want this pipeline to be created in main. So what I'm going to do, I'm going to first get this one, copy this whole thing. Okay, and I'll go to dev branch, and there I need to create this file. Click on dev. Okay, and I'll create new file as .github/workflows/ then I'll write maven.yaml and paste the files here. Okay, now let me explain you. This is going to be just the name. It's going to be CICD, and next up we have trigger, basically on what actions I want my pipeline to get started. So I'm setting up that as soon as any commit or as soon as any push is happening to dev branch, pipeline should be getting started. Also as soon as any pull request is happening for dev branch, pipeline should be getting started. Then we are defining jobs. In jobs, only one job I'm defining, because if you want to run multiple stages at the same time or simultaneously, then you can define multiple jobs. But at this point what I want, that all stages should be run sequentially. Okay, after that we have runs on. Basically it defines where exactly you want to run your pipeline. Ubuntu latest means that we are saying that we want to run this pipeline on GitHub hosted runner, but I want to run my pipeline on my self-hosted, right? So I'm going to provide the tag which is self-hosted, if you remember correctly. Where exactly do you need to remember? So if I go to settings, go to actions, runners, here you can see these are the labels. So first label is self-hosted, and that's what I have written here. Next up what we are saying, that we want to use JDK 70. Okay, now very important thing about GitHub action that you need to know is this section uses. It is basically a action. Here basically you want to perform something or using specific tool, that instead of installing that tool directly, you can directly use or call out the action to use this. For example, we are not using Java, we have not installed Java on our virtual machine, but using this action and defining which Java version we want to use, we can install it directly, right? That is the good thing. And here also what I'm running, I'm simply running Maven package. Let me remove P, this is not needed. Here you can see this section --file pom.xml. So basically by default pom.xml exists on the root directory, but in case it's not present on root directory, then you need to provide the path of it by --file. What we can do now, we can commit these changes and let us see what happens next. Okay, so I have committed this, and we can click on this repository, go to actions, and you can see pipeline has started. right? Click on this and we can check out like if our stages are running fine or not. Okay, as of now this I'm running only on the dev for the dev branch, and this is for dev cluster only. Okay, so let's wait for this to complete. See, that is the interesting part of GitHub Action, that you don't need to specifically install multiple tools on the virtual machine. You can do it like you can directly you call the action in your pipeline and then you can utilize it. Okay, let's check out and let's wait for this to complete. And you can see it is successful. Now we can see application got built, right? This is fine. Now what we are going to do, we need to add multiple stages in our pipeline. So for that, let us go to dev branch, and here go to workflows. Next step that I want to add in my pipeline is basically to perform the file system scan on my source code. How we can do that? So I'm going to create a copy of this stage. Okay, and here the naming of the stage will be 𝗘𝘅𝗰𝗹𝘂𝗀𝗃 scan. Okay, this run that you are seeing, if you want to just run shell command, you can use run. Okay, I can write the steps as 𝗘𝘅𝗰𝗹𝘂_format, in which format we want the reports. So I want the report in table format, and in which file I want the report, -o file I want the report in fs.html. Okay, after that just put a dot, that means I want to scan current directory. Okay, this is fine. Next step that I want to execute, it's going to be SonarQube analysis. So for performing SonarQube analysis, we need to make sure that on our runner, or like SonarQube server is set up somewhere. Okay, so I'm going to set up on the SonarQube server directly on the runner itself, because you can set up on other machine also, but just for the ease of it, I'm going to set up SonarQube on the runner. Okay, Docker. So we need to install Docker because I'm going to set up SonarQube using Docker container. Okay, and let's wait for this. And as you know, by default, when you set up Docker, only root user has permission to execute Docker commands. So what we can do, we can use sudo, then docker run -d. -d means running in detached mode. -p means we want to publish port. Which ports? 9000, the first port, which is going to be for host port. What is host? This virtual machine is the host. Second port is going to be 9000 again, but this port is for container. Okay, and then we need to provide the name of SonarQube image. I'm going to use SonarQube:LTS-community. Okay, click enter. And this is going to set up SonarQube server. So let's wait for this to complete. Now, one thing that you might have known previously from my previous videos, that usually when we want to work with SonarQube, two things we need to have. One, we need to have SonarQube server where the report is going to be published, where we can analyze it. And second thing, we need to have SonarQube scanner. Scanner is the one who like perform the analysis, generates the report and publishes it on this server, right? Now we have set up server, but what about SonarQube scanner? So that's where the benefit of this GitHub Actions comes. Here we can simply call an action that is going to set up SonarQube scanner. Okay, let me show you. First of all, let us access our SonarQube server. It will be running on port 9000. Let's wait for this. You can see SonarQube is in starting state, so let's wait for this to complete. Meanwhile, talking about writing the stages. So as I've explained you, whatever stage I want to use, I can simply utilize it by calling different kind of actions. You can see here we are using the action SonarQube scan. What it's going to do, it's going to set up a SonarQube scanner to perform the scanning. So I'll copy this and I can, one second, let me set up this. By default, SonarQube is having username, password, admin, which we need to change. And you can put the password here, anything you want. Click on update. Okay. Going back to our pipeline, here I can add the stages steps for SonarQube analysis. Now here you can see the stage name is SonarQube as scan, and very important thing that we need to have is SonarQube token and host URL. So where exactly do we need to add it? If I show you, here you will find one section inside settings, you will find one section secrets and variables. Click on that and click on first one, which is actions. Now here we need to add secrets. Okay, so I have added secret from previous one also, like previous practice. Here just remember that you need to click on new repository secret, provide the repository secret name and its value. Okay, for example, for SonarQube host URL, so I'll click on edit. For value, I'll copy this URL and paste it here, remove the last slash, click on update. Okay, second thing that we need to update, it's going to be Sonar token. So where we can get it, we need to go to SonarQube server, administration, security, users and administrator. Okay, here we can create a token by providing any name, and this token is going to be the secret for our SonarQube token. Okay, click on update secret. Once you do this, that means by default this stage will work fine. Okay, now one question you might be thinking, Aditya, generally when you run SonarQube analysis, you provide the information about project name, project key, as well as Java binaries location. So where exactly we are doing that? So in this case, where exactly we need to do that? We can go to repository. I'll go to dev branch. And here you see this specific file sonar-project.properties. This is the file you can see. It contains, I have added it here, taskmaster and binaries location. Okay, so this is where you can put it. Let me change the information to target. Basically Java binaries file will be stored inside target folder. Click on, okay, let's not commit right now. Okay, let me just basically see what's going to happen if I commit it right now. It's going to trigger the pipeline. No problem, let us commit and we will cancel the pipeline. Click on this. Let us cancel this. Okay, now this is added, so now we can commit the changes. Click on commit, and now the pipeline that got triggered, that we can monitor. You can see this one here. This is the job, and this might take some time to completely get in running status. We can go to our runner, and here also we can see that first pipeline we can succeed, it was success, second one I cancelled, and third one is just in running status. So let's wait for this to complete. Which one? So let me go back to dev and let's see what we have added. Okay, so pipeline seems correct, but still we got the error. But yeah, let us check out what exactly was the error and then we can fix it. Or it says, okay, Docker permission is not given by default. Let me fix it. In that case, what we can do, we can execute this command to make sure that Docker permissions are available. I can run this on my runner, and let us trigger the pipeline one more time. You can trigger directly from here, rerun jobs. Okay, and now we can monitor and let us see what happens now. Okay, next job has started, and let us see now. Now you can see SonarQube stage is working fine. This was failing because by default, as I told you, by default when you set up Docker, by default not all users are having permission to execute Docker commands. That's why I have to run the command with sudo. But I just gave the permission, and then we are able to execute all the stages that we have. Okay. Okay, last stage is happening, which is 𝗘𝘃 scan. Okay, second last. Now SonarQube is happening. Okay, so let's wait for this to complete. And we can see the status here as well. We can go to projects, and once this part is completed, then we'll be able to see the published report. Okay. Let's wait for this. Okay, now if I refresh the page, can see project is created inside SonarQube as well. Okay, that means pipeline is working fine. Now what we have to do, we have to add the stages for Docker, right? We want to build Docker images. For that also, what you can do, as I told you, whatever stages I'm using, it's not key manually you have to write everything from scratch. For example, if I show you, if I copy this and you just need to go to GitHub Actions Marketplace and you'll find everything. For example, if I want to perform Docker build and push Docker images, I can go on you can see this Marketplace Actions, and here you can search. And all the stage that I want to use is already present. I just need to copy and paste it. Okay. Same thing I need to do here. We can copy the steps for building Docker images. This one. I will copy that and let us paste it here. Now what is happening? Two things you will be able to see: Docker buildx and 𝗘𝘅𝗰𝗹𝘂𝗀𝗀. 𝗘𝘅𝗰 is short for quick emulator. Basically, when we want to use Docker images that requires different kind of architecture to run, in that case, quick emulator is very helpful. For that reason, I have just added it. And buildx is another component of Docker which is required to be available for Docker to work well. Okay. Next up, what we need to do, we just need to run the command. One difference you might be able to see here in the command, I'm using pipe and I'm writing it below. So basically, if you have multiple lines of command, you can treat them separately by using this format. For example, here if I write echo Aditya, that means these are two different commands. Okay, so for that you can use pipe and it's a very good option. And here we are going to change the Docker image name. Docker image name, it's going to be dev task master. Okay, that is fine. Now it's basically what we are doing here. We are building a Docker image. Okay. After this is done, what I want that my Docker image should be pushed to Docker Hub repository. But before that, I want to scan my Docker image. For that, I can use 𝗘𝘅𝗰𝗹𝘂𝗀𝗃, right? So I can create another stage for 𝗘𝘅𝗃, and here let us name this to 𝗘𝘅𝗃 image scan, and this will be image format table, and naming will be image.html. And we need to provide a Docker image name here. That we can do, copy this and paste it here, right? Next up, what I want that my Docker image that I have just built, it should be pushed also to Docker Hub repository. For that also, you can get the steps from here. Don't worry, this pipeline I'll be sharing with you, so you don't need to worry about that. Now, here what we are doing, first of all, we are logging into Docker Hub repository, so that once we have we are logged into Docker Hub repository, then we'll be able to push a Docker image, right? So you can see these are two secret variables, right? Docker Hub username, Docker Hub token. That also you need to provide the values of these secrets. You need to go to settings, scroll down, sorry about that, settings, scroll down to secrets and variables, GitHub Actions, and here you can see these two tokens I have added. First one is for Docker username, and second one is for Docker token, basically Docker Hub password. Okay, and that is fine. Here we just need to change the Docker image name, the one that we are using. I'm going to put the Docker image name as this one. And now this will be using these two steps, we'll be able to push our Docker image to Docker Hub repository. Last thing what we need to do, we need to deploy the application to our Kubernetes cluster, right? So for that, what we need to do, first of all, I'll go to this master node. This is the self-hosted, right? This is the dev cluster. So what I need to do, first of all, I need to go to this folder. Here you see this file config. If I run this cat config, now these things that you are seeing, these are the actual kubeconfig file for dev cluster that will be used for authentication, right? How we can use it? So first of all, basically we need to create another secret for this this one, Kubernetes kubeconfig. Okay, you can see there is another kubeconfig added. Let me just rename this. We need to update its value, right? Now value, what is the value that we need to put? So we need to put the value of kubeconfig, but not in general format. We need to make sure that it is encoded in base 64. How we can do that? right? So for that you can use this command, which is going to encode it into base 64. Okay, click enter, and now this file that you are able to see, this is the same kubeconfig file, but this is encrypted in base 64. Okay, so I'm going to copy this whole thing, copy here, and let us paste it here in kubeconfig and click on update secret. This is done. And now here one last stage we need to add, which is going to be for kubectl actions. For example, if I copy this, you can see again I'm saying whatever actions or steps I'm writing, I'm able to write from marketplace actions. Okay, if I scroll down, you can see all these things here. Same thing we need to do. I'm going to copy this, go back to our DO pipeline. Okay, here also you can see that we are directly using kubectl available, and then we are going to perform the deployment. Okay, one more thing that we need to do before we commit this, we need to make sure that this Docker image is added in our YAML file. So I can go to dev branch deployment service YAML and change the Docker image name. We can change it from this one to this one, dev master, right? And this is done. Let me comment the changes. Okay, one pipeline might be triggered. Let us just cancel it. Okay, now once I commit these changes, then our application will be deployed to dev cluster. Okay, so I'll click on commit changes, and this will trigger a pipeline. Okay, now let us monitor this and let us see what happens now. Okay, and again this might take some time because we have lots of stages added. Okay, so let's wait for this, and once this is done, then we can proceed with the deployment of application over prod cluster, right? That also I'll explain how it's being done. Sample I already explained through this diagram, right? Yeah, Maven is going on. Okay, so I'm not stopping or skipping this because let us just monitor the logs whatever we are getting, so that it's easier. If an error comes, we can just figure it out, right? So our kube analysis happening, and previous stages are already fine and successful. Now it's going to build a Docker image, and it's going to push the Docker image to Docker Hub repository. Okay. Okay, Docker image is, I guess it's built. Okay, it's, yeah, Docker image built. Now Trivi is going to scan that Docker image so that we can check out the report, right? I guess Trivi is also almost completed, and after that it's going to log into Docker Hub repository and then push the Docker image to Docker Hub repository. Okay, let me just, okay, now it's logging into Docker Hub, and yeah, now our Docker image is getting pushed. So let's wait for this to complete, and after that our application is going to be deployed to Kubernetes, self-hosted Kubernetes cluster, which is for dev cluster. Okay, and okay, so we have small issue, I guess, naming convention issue. Basically you can see, if I show you Taskmaster Pro, let's go to dev branch. Here we have YAML, right? But in our pipeline we have written YAML, I guess. Yeah, that's why we are getting issue. So I'll just remove the A from here and let us commit this again. Okay, so yeah, this will take few minutes, and this time I need to skip it because already we check out. Okay, so yeah, once this is completed, then I'll be back. So team pipeline is successful and it is completed. Okay, just to confirm what we can do, we can go to our master server, master node, and I can run the command as kubectl get svc, and we can see that our application is task master SSV service is created. How we can access it on this port, right? And this is deployed on worker node, so I can get the IP address of worker node, this one, and 32560. So we can try to access our application here, 32560, right? Click enter and let us see. You can see application is deployed. I can sign up here, and then I can log in also. Okay, application is running fine, right? That means we have successfully deployed our application on dev cluster. Next step would be to deploy the application on master, basically prod cluster. How we can do that, and what would be the best practice to perform that, right? So let me explain you that as well. I can go to main branch first of all, and here we can click on actions and we can create our pipeline. Okay, click on new workflow, Java with Maven. Now, one thing that you need to understand first, that whatever security stages and building of application, everything we already did in previous environment, that is for dev. That means the Docker image that was built in for dev cluster is already very secure and everything is ready. That means we can use the same Docker image to deploy to our prod cluster. Okay, but directly we are not going to use the Docker image. We need to tag it in a different name. Let me show you. I'll write cd prod, and this will be self-hosted, and here first of all let me remove optional. Actually we don't need this. This also actually we don't need. Sorry, let me, yeah. So what we can do, we need to add Docker stage. Okay, and what exactly here we need to do, let me explain you. I'll copy this command and okay, so we are first logging into it, and what I'm going to do, Docker pull, then the Docker image name that we have used for our dev cluster. Okay, and I can get it where, sorry about that, it is in dev branch, right? So we can go to GitHub workflows, Maven, and Docker image name is this one. So I'm going to copy that, paste it here. Okay, it's going to pull it. Then what I want to tag this Docker tag so and so, and this will be tagged to a new name, which is going to be 𝗘𝘅𝗰𝗋/ prod taskmaster : latest, and then Docker push the new Docker image, right? And I can paste it here. And what I need to do, we need to add the last step, which is deployment of application, right? I'll copy this and let us paste it here. Okay, and make sure your name is correct. Okay, now kubeconfig, I'm going to provide another name, which is going to be kubeconfig prod, right? Same thing we need to do that we did in case of dev cluster, right? For that, what we can do, we can go to our server, EKS cluster server. Okay, if I go to this location /.kube, you can see we have the config file, right? That means we need to encode it into base64. That we can do using this. Copy that. Okay, and I'm going to copy this whole encoded file. And now what we need to do, we need to create another secret. Okay, for that we can go to settings, secrets and variables, actions, new secret, value will be this, and secret name. So what will be the secret name? In our case, the secret name will be 𝗘𝘅𝗰𝗹𝘂𝗃. So I'll copy that, add it here, and add secret. Okay. And one more thing that we need to do is update our YAML file, right? So I'll go here, and here we need to update the Docker image name. That we can get it from here, paste it here. Okay, let me commit, and I'll just cancel the immediate pipeline that got triggered. Okay, sorry, we have not yet pushed our pipeline, so yeah, right. So now everything is done. Now we can push our pipeline as well. Click on commit changes, go to actions, and here we can see the pipeline created for CD prod, right? And now we can monitor what exactly it does. So let us see. See, new tagging is done. Okay, 1 second. Yeah, okay, so it is pulling now the dev cluster Docker image. Once it is pulled, it's going to tag it, and then it's going to push it. Okay, we have some error, and let us see what exactly is the error, and then we can fix it. Elevated deployment service, elevated data. Download open API. It's not found. Okay, so let us fix this issue. Okay team, so what exactly is the issue? It's not able to validate over EKS side, basically over AWS. Okay, so what we need to do basically here, we need to set up AWS CLI on the runner so that it will be able to connect to AWS account. Okay, so for that what we can do, we can go to our runner. Here we need to install AWS CLI, and that we can install. Copy this command and execute it directly. And after that, we are going to run AWS configure command. Okay, let's wait for this. AWS configure, and the access key and secret access key that we generated, that we can utilize here. Okay, this is the access key. Copy that and paste it here. Then secret access key, which is this one. Region is AP-south-1. Click enter, and again click enter. Now the runner is authenticated with our AWS account, right? So now we can let us re-trigger it. Okay, so I have started it again, and let us see what happens now. This might take few minutes, so let's just be patient, and then we can go ahead with this. Okay. Okay, this time it seems it is successful. Okay, you can see here a deployment created and service also created, and we can see the pipeline is success. Now we can I can run the command from here on our Terraform server as kubectl get all, and we can see application is deployed, and we can copy this, run this in the browser, and we should be able to see our application. Okay, do not worry about this. This takes few minutes to completely come up in running state. Okay, let's wait for this. So, okay, meanwhile let us just check immediately our the logs of the pods, kubectl logs, and we have these pods. Wait, let me install kubectl also. Okay, we have that. One second. Sorry about that spelling mistake, small spelling mistake I have. kubectl logs. Okay, it seems application seems up. Yeah, here also you can see now on our load balancer URL application is up. We can sign up also, can provide some user ID password, and we can log into it, and you can see application is up and running now, right? So yeah, this is how we can perform complete CI/CD deployment from like on one cluster and on the second cluster. Okay, so I hope this video was useful, and I hope you will learn it, you will practice it, and make sure once you are able to complete it successfully, you can post it on LinkedIn. It will get you a lot of a lot of HRs are also there, that they can check it out, and I hope it brings you some usefulness. Okay, so yeah, thanks for watching and have a nice day, and make sure if you are interested you can enroll to batch 6 also. Okay, so yeah, thank you.